Alright, functions and relations. I'm really just going to do a bunch of definitions today. So let's start off with the big picture, which is what is a relation? And a relation is any ordered pairs or set of ordered pairs, also known as points, in a coordinate or Cartesian plane. So any sort of graph you can think of, just a bunch of random dots on the page, those are all relationships of data, so they're known as relations. We're going to care a little bit more about certain kinds of relations and certain qualities of the relation. And one of those main things that we care about is something called domain and range. And the domain is of a relation is all the x values of all the points in that relation. And sometimes you just list them out, and sometimes there are more efficient ways, and we'll get to that in a second. And similarly, the range of a relation is the y values of those points. Now, if you just have an equation, sometimes you can determine what the domain is just by inspecting the equation. For instance, if you have an equation f of x is equal to x minus 1, the domain is the x values of the points that can be on that function, and we should know that inside the square root needs to be bigger than or equal to 0, and with some easy manipulation you can quite quickly find the domain algebraically, or by inspection if you just look at it. For rational functions, so if you've got f of x over g of x as a rational function, of course the denominator has to be non-zero. So, and that will be your domain. There are a few different notations for domain. One of them is interval notation. So in the example that we had above, we used a notation that looked like an inequality sign, and that's perfectly fine to use. That's one type. Another way of saying all the numbers greater than or equal to 1 is to use set notation. And set notation is x in these special brackets. X is defined by x is greater than or equal to 1, and x is a real number. So that symbol there is the real numbers, and if you haven't seen this symbol here, it means belongs to. For these sorts of domains, we don't want to have to list them all out, but you can just use lists, you can use number lines, you can write it in words. But my favorite is to use what's called interval notation. And interval notation takes x greater than or equal to 1 and it makes it look like from 1 up to infinity. And the square brackets means it includes, and the soft brackets means it does not include. You can never include infinity or negative infinity, and these interval notations always start with the lowest number and go to the highest number. We'll see some more examples of it as we go along. You can use this notation for range as well. So instead of x, you're just using y's. For each x value, there is only one y value for a function. For example, if you are given a graph and you see a function that looks like this, you can tell that for each x value, there's only one y value. A special type of function is a one-to-one function, and a function is one-to-one if for each x value there is a unique y value that does not correspond to any other x value. There are quick tests if you have a graph for both of these to tell if things are functions or if they're one-to-one. One of the tests, and you may have seen this in the past, to see if you have a function is called the vertical line test. If you take a vertical line, so a line straight up and down, and you run it across your graph, for instance, if you run it across this graph, you'll see that all the times that you run a vertical line across the graph, you will hit only one time. And the vertical line test says if you hit only one time, Never twice, never three times. If you only hit once, then it is a function. The similar thing happens if you are looking at a one-to-one function, except you use a horizontal line test. So when you run horizontal lines across, if you hit more than one time, like I did here, or like I did here, then you can tell if you have a one-to-one function. In this case, I do not have a one-to-one function because it fails the horizontal line test. You should probably add a little bit into your notes about the vertical line and horizontal line tests.